Warriors, this is your Pathfinder series and you are in the crash course where in one shot we are going to cover magnetic sources, Ampere's law and Biot Savart's law. All with me, Shreyas, your physics master teacher and Vedantu going live. Hello Rays, hello Ankita, hello Venkata. Good evening my lovely warriors. I am Shreyas. I am a graduate from NIT Nagpur and I graduated almost maybe 13-14 years back, and I have been training kids after I left my software job, and here I am today to train you, to coach you and to make sure that you excel in your studies. And we have one common motive and we Enthuse to make sure that you guys get your desired college, to make sure you do not have any backlogs, to make sure you understand the physics concepts, chemistry concepts, maths concepts, and you fall in love with the subject and you know the right way to crack these examinations. Now Pathfinder is a long-term series, so if you are looking forward to complete your entire term 1 syllabus, we already have a playlist. You can watch it. I have completed the entire physics portion for the term 1. So now I'm trying to cover up all the chapters in one shot so that you quickly revise and clear all your backlogs. So welcome aboard. Hi Dalston. Nice to know that you are watching me first time live, and I hope you will be a regular follower. Hi Suhita. Hello Dhruv. Hi Sri Akash. Good evening. Nice to see all of you changing your display pictures to Enthuse logo. So if you want to know more about me, you can obviously follow me on my Instagram handle, that's Shreyas_Vedantu. Now before we begin the class, I would like to proudly tell you about what Vedantu has done in the last few days. And if you have been following Vedantu or our YouTube channels regularly, you know that we had some amazing results this year in JEE Mains and also in JEE Advanced. So we have created history. We have broken our own records, and there were more than 1,500 students from Vedantu who cleared JEE Advanced. I'm not saying people who got from mains to advanced, people who cleared JEE Advanced, who got an all India rank in JEE Advanced. Last year this number was 500. Next year this number will be even higher, and the year after that we will be even stronger. And the best part is 60% of these students were from small towns where they did not have access to quality education. If you compare the ratio of the students getting into IIT JEE Advanced in Vedantu, it was much higher than the national average or other coaching institutes. So this is the power of our teaching, and we have really created some amazing heroes. These are our achievers. It's not just about the topmost rank. It's not just about the top 50 or the top 100. It's all about whether we have been able to create a difference in the student. A student who used to get very low or average marks, are we able to lift him up and get him some decent rank? So 2000 rank, 3000 rank might not sound great, but each rank is a story in itself, and that's what these young achievers have done. And if you think you also want to create a story, if you think you want to get a nice all India rank, then you should first of all feel very proud about all the dear Vedans, and welcome all the new warriors. Yep, I know Dhruv, it's complete fire from Vedantu. Purvan asks, whatever is your problem, please let me know, bacha. Please don't feel hurt for any reason. They're always there with you. Yep, so let's get going. And if you really want to be a young achiever, if you really want to create a story of your own, I would say please join our Vedantu courses. And there is a crash course for term 1. There is a course for term 1 plus 2 CBSE. There is also a course for JEE, and that too for students who have started late preparation or who have realized that, okay, I have not studied much or I did not get too much of input from my coaching and you are not happy. Then there are courses for every person that you can think of, and they are for as low as 3,000 rupees, and there is Dashera sale going on. So when you use this coupon code, you not only get 10% off on monthly installments, but also the year long you get flat 10% off. So that's our Dashera sale. So please check out the link in the description box. Today is the last day. So after tomorrow, you will not see this Dashera sale, so you will not be eligible for the offer. So go ahead and check it out. So let's get going. Hi Dark Angel, welcome aboard. Hi Gokulnath, welcome. So today's session, yes Dalston, it's for term 1. So let me also tell you over here, if you are in the playlist, okay, so if you go to our playlist, I have already covered everything. I'll just show this to you. So just go to JEE Physics, okay, once again, not this one, JEE Physics preparation. So just click on this and you will see all the different playlists. This one is for the strategies, tips and tricks and all of that. Then this is a nurture playlist, this is the Pathfinder playlist. So if you click on this, you will get the entire lecture series. But if you want it chapter wise, you go little bit down and you can see electrostatics, Gauss law, current, capacitor, magnetism, EMI, AC, everything separate. But if you want it as one single playlist, then you just click on this, you will get the complete playlist right over here. You can see that this is the complete playlist. Okay, so it's up to you how you want to watch it. All the lectures are there. So today's lecture is all about clearing your backlogs and making sure you feel a little bit more confident on these topics. So let's get ready. Yep, Urja, this is a kind of a crash course. So these are one-shot series. I have already done 3 one-shots. Okay, one on electrostatics, one on Gauss's law, current, electricity and capacitors. So all these one-shots are done, crash course. Okay, so right now we are in the magnetism. So if you have missed these classes, don't worry, you can still watch it as replay. It's all there. Okay, it's all there in these playlists, the one which I just showed you. You can cover it up. So just take out the time. You will hardly take 4 to 5 hours to complete your previous backlogs. Okay, through these one shots. So try to do that. And if you have any difficulty in a specific topic, then watch the specific lecture of that. That's how you can easily cover your backlogs and you have good 1.5 months of time before your board examinations. Shall we begin? Raise FS, yes. Even if you have a physics model exam tomorrow, you can definitely watch the one shots and that will definitely help you. So let's begin, my warriors. Okay, so first of all, what was Oersted's experiment? Oersted was the guy who saw that whenever you pass current inside a wire, that created magnetic field, and the way he demonstrated that was by passing current and holding a magnetic needle around it. He saw that the magnetic needle deflects whenever you pass the current and the deflection reverses when you change the direction of current. He also saw when more current is passed, then the deflection is more. That means the magnetic field produced around it is more. And as you took the magnetic needle away from the wire, this wire carries that current, then the deflection reduces. That means as you move away, the intensity, the strength of this magnetic field also reduces. So this is what the Oersted's experiment is all about. So whenever you pass some current, it produces magnetic field. So if you take a coil, okay, if you take a coil and you pass that current, it behaves like an electromagnet. Why is it an electromagnet? Because it is not a permanent magnet, because it shows the magnetic properties only till you pass the electricity in it. The moment you disconnect the battery, there is no current, there is no field, it will not show magnetic properties. So that's why it is an electromagnet, because it is powered by electricity. Now, magnetic field is a vector quantity. It has the same properties just like electric field. The unit of magnetic field is Tesla. There is only one difference in the property of magnetic field. Who can tell me the difference in the chat box? Meanwhile, let me show you the common properties. The common properties are something like this. So, if the field lines are parallel, then this is basically uniform field. Okay, this is uniform field. But if you have the field lines going like this, okay, this is non-uniform. This is non-uniform field, and here the field intensity, because you can see the density is more, it is crowded. Here the field is more, here the field is less, where it is less crowded. You also know one more thing, that two field lines can never intersect. This is not possible. Okay, this is not possible. Very, very important property. Let's see how many of you have written it down. Hi Chitra, hi Naveen, welcome aboard. Hi Surya, good evening Bachalo. Yep, so there is only one difference between electric field and magnetic field, and that is magnetic field lines are always going to start and end at the same point. there is no origin for that. Basically, they are always in the form of closed loops. There is no start, there is no end. Okay, so that's one major difference. But we know electrostatic field lines, they start from a point charge and they end at another point charge. So that's what it is. So these are the different properties which you should know for magnetic field. The symbol is B, unit is Tesla. 1 Tesla is a very, very big unit. Yes, Dalton, I'm going to do a lot of problems. Theory problems. So lots of problems coming up. So quickly revising through all the theory. Okay. Next. So hold on, guys. We are going to do everything. Yes. Nanta Kumara Sakna. Yes, it is bacha one shot. So quick revision of the theory so that you get used to all the formulas. And then problems coming up. I hope that is exactly what you want, because that's what a proper revision is supposed to be. You cannot just have only problems. Okay, don't worry, we are going to have amazing problems. In fact, I have planned some PYQs also. There are some PYQ problems also. You will see that. So Biot Savart's law. So what is Biot Savart's law? It is the quantification of Oersted's experiment. So Oersted gave you all the observations that current produces magnetic field. Biot Savart's law tells you what is the exact value of the magnetic field. So I'll explain you all these things over here. If there is a wire which carries current, okay, like this, then around it, it is going to produce magnetic field. Let's say I am here and I want to know what is the magnetic field at this point due to this wire. So this wire will produce magnetic field. That means every part of the wire creates magnetic field. So I take a small element of that wire and that element will produce a magnetic field. This element will produce a magnetic field. This element will produce a magnetic field. This element will produce a magnetic field. Each element produces a magnetic field. So he gave the formula for the magnetic field produced by an element of length dl at any position. What is that position? Denoted by r. R is the position vector of the point where you want to find the magnetic field. What is r? R is the position of that point with respect to that element where you want to find the magnetic field. How much is the magnetic field? It is dB. Why is it dB? Because it is the magnetic field of a small element. When I add the fields of every element, the total magnetic field will be the integral. It will be the sum. It will be the addition of all these dB. So when you add all the dBs, it will become B. Is that clear, my warriors? Okay. So that formula is given by mu naught by 4 pi. Very, very important. Look at this. The dB formula is mu naught by 4 pi. Mu naught is basically the permeability of free space. Okay, permeability of free space. Okay, and IDL cross R upon R raised to 2. Okay, this is R raised to 2 and this is R hat. What is R hat? R hat is unit vector, unit position vector. So it will be R vector by R. Haven't you studied this back in 11th grade in vectors? This is unit vector. Any unit vector A hat will be A vector divided by magnitude of A. You would have studied that. That's what this is. So dl cross r hat divided by r square, and the value of mu naught by 4 pi is 10 to the power minus 7 in SI units. That's a standard constant value which you should remember. Now, if you do this cross product, look at this. dl is here, r hat is this way. dl, so use your right hand, use your 4 fingers, put the 4 fingers in the direction of the first vector which is dl. Cross r hat. R hat is here. dl cross r hat. Where is my thumb going? Thumb is going inside. That means my magnetic field will be inside the plane of the board. So that's what this is. So dB is going to be inside in this situation. So I will show it like a cross. What is this expression telling me? To find the net field, because each element produces field, the total field by the complete wire will be the sum of the magnetic fields of each of the elements. So that's why integral. I hope this makes sense. Is that clear? Everybody remembering all of this formulas? Everybody clear about these notations. dl is the element, r is the position vector, r hat is the unit vector of that position. And the magnetic field by Biot Savart's law is mu naught by 4 pi, where mu naught by 4 pi is a constant whose value is 10 to the power minus 7. IDL cross r hat divided by r square. That's it. Okay. What is dB, Dalston? dB is the magnetic field produced by only this part of the wire. Each part of that wire, dl, will produce small magnetic field dB. Other element will produce another magnetic field, another dB. So all the dBs due to all the parts will add up to give you the total field due to the entire wire. I hope that makes sense now. Okay, so that's why I'm calling it as dB. Now using the integral in my regular classes, I have found out the magnetic field for all the geometries. So let's quickly revise the field due to all the geometries. But before that, you should always visualize how the field lines look like. If you don't know how the field lines look like, then for sure you are bound to make mistakes and you will not get a feel of that topic. See, if there is a loop, circular loop carrying current as shown by the red arrow mark, the magnetic field lines produced around it look something like this. Very interesting diagram. So, how do you know whether it goes like this or whether it goes like this? Very easy. Use your right hand. Okay, use your right hand, take your 4 fingers and turn it, curl it around the direction of the current. See how the current is going? See, the current is going like this. See, where does your thumb go? The thumb is going like that. So that's why the magnetic field lines will come like this. If the current goes like that, okay, this way, then your thumb will point downwards. So then the magnetic field lines will be like this. So basically the direction of the current decides the direction of the field lines. Notice one more thing, the magnetic field lines do not start or end anywhere. It's continuous loops. There is no origin, there is no termination. That's what you can see. Now there is a magnetic field formula for the center of the loop and on the axis. So what is the field on the center and what is the field on the axis? Let's just quickly go through it. So if you have a loop which carries current, what is the magnetic field at the center and what is the magnetic field on the axis? Let's quickly write it down. Yes, Faza, this is one shot. Hi Ankit, long time, where were you? Okay, so welcome. I'm not sure about it, Krishna. Okay, so first of all, at the center, remember it is mu naught I by 2r, standard formula. Mu naught current by 2 times of radius. Second formula, on the axis, that means you are some distance away from the center. It is mu naught I r square by 2, r square plus x square whole raised to 3 by 2. What is x, you might question? X is nothing but this one. This is x. Now you can get this formula from this formula. How? If you put x is equal to 0, that means I am located exactly at the center. I am not located away from the center. Just substitute that and see what do you get. You will get mu naught I r square divided by 2 r square, x is 0, whole raised to 3 by 2. Square and root will cancel. So you will get mu naught I r square divided by 2 r cube. One of the r will remain because r square and cube will go. So this is nothing but this. So substituting x as 0, you get this original formula. So this is the more important formula because you can easily derive this formula from this formula. So very important. Okay, mu naught I r square. How do you derive these formulas? Very important question, Shaurya. I have shown you all these questions and how to derive that in my regular classes. There is a playlist. I have shown you how these formulas come. Please watch that playlist because today's lecture is a one-shot backlog clearance. Understand the application of these formulas. Is that fine, bacha? So do that. All right. Yep, Amina. Yes, this is enough for term 1 because in your board examinations at least you don't have your derivations because it's completely objective, case study based and assertion reason, these kind of questions are there. So it's completely objective. So if you are preparing for KVPY and JEE, you're automatically easily preparing for your board examinations as well. Okay, one more thing that I want you guys to know. See, if I have a loop which carries current, okay, using my right hand rule, I can see the thumb is coming outside. So the magnetic field will be here. okay, like this towards me, and that B will be given by mu naught I by 2r. But what if the loop is not complete circle? What if it is a semicircle? Okay, if it is a semicircle, it's not a complete loop, then the magnetic field won't be this value, because each semicircle will produce the same field. So this magnetic field by the semicircle will be exactly half of this. So it will be mu naught I by 2r. As simple as that. It will be half of this value. Make sense? Everybody clear about this? What if it is something else? What if it is making some angle? What if it is making some angle theta? Okay, this is the current. Then the magnetic field will be mu naught I by 2r just multiplied by theta and divided by 2 pi. Why should I do this? Why is this number important? Think about it. Theta by 2 pi tells me the fraction of the arc as compared to the complete circle. If theta is pi, that means it is semicircle. Pi by 2 pi is half. You can see that half came over here. That is that half. If it was 1/4, then theta will be most likely pi by 2. So pi by 2 pi is nothing but 1/4. So accordingly, this number will come out to be a fraction of that complete circle. Make sense, everyone? Okay, I hope this is very clear. All right. KVPI syllabus is very similar to whatever you are studying in JEE 2022 Shaurya. All right. Yeah. Cool. Hi, Mr. Terrible. Welcome aboard and welcome to this class. Next geometry. What is the next geometry? It's a long straight wire. When you have a long straight wire, then if there is current flowing in it, then the magnetic field around it is circular loops. So if the current is going like this, take your thumb and point it in the direction of current. The fingers automatically give you the direction of the magnetic field lines around it. That's all. Okay, so the magnetic field lines look somewhat like this. Now, most often you get formulas or questions where the wire is infinitely long, but there are situations where the wire might not be infinitely long. It might be a finite wire. The wire starts from here, ends here. There is only current in this much part. And then you have to find the magnetic field only because of this part. What do you do in such cases? This is your wire, the red one, which carries current. You want to find the field over here. Where? At point P. First thing what you should do, drop a perpendicular. That perpendicular distance is R. Fair enough? Join the ends of the wire. The green lines are the ends. Check what is the angle made by the perpendicular with the ends. Those are alpha and beta. Fair enough? Then the formula for the magnetic field which comes via integration is this one. Mu naught I by 4 pi r sine alpha plus sine beta. Very important formula. Mu naught I by 4 pi r. Remember, there is pi over here. In the previous formula for circular loop there was no pi. So it was mu naught I by 2r. Okay, for circular. But for straight wire it is mu naught I by 4 pi r sine alpha plus sine beta. Sine alpha plus sine of beta. But when you have an infinitely long wire, then what will happen? This point and this point are at infinity and minus infinity. This angle alpha and beta both will become 90. Sine 90, sine 90. Sine 90 is 1, sine 90 is 1. 1 plus 1, 2. 2 and this 4 gets cancelled and you'll get 2 pi r. So that's the formula for an infinitely long wire. Yep. Yes, Amina, very true. Welcome, Jat Sandeep. Welcome to this new class for you. And I hope you will continue your journey on Enthuse. Do not forget to hit the subscribe button. And if you are already subscribed, do not forget to also hit the like button to show your love and support. Okay, let's start solving some questions because I know you guys are eagerly waiting for solving some questions. And here is the first question on the screen. There is a straight section PQ of a circuit which lies along the x-axis from minus a by 2 to plus a by 2, and it carries some current I. The field due to this section at x equals to plus a and another point a by 2 and a respectively will be how much? Hello Prabha, welcome aboard. Let's see how many of you warriors can start this question. My day is good. I hope you two are having a very amazing day. And let's make it more amazing by revising the entire magnetism sources for, like Oersted's experiment, Biot Savart's law and Ampere's law and all the geometries which create magnetic field. So that's what we are discussing today. So first of all, I have my x-axis. Okay, this is my x-axis, fair enough. And let's say this is my y-axis. Okay, this is my y-axis. And the wire is lying from minus a by 2 to plus a by 2. Okay, this is the wire. Okay, so this is minus a by 2 to plus a by 2. Now where and all do you have to find out the magnetic field? One point is plus a. X is equal to, oh sorry, this was supposed to be, yeah, plus a, correct. So x is equal to plus a is here. So x is equal to, okay, plus a. The second point is x is equal to a by 2 and y is y is just a. So y is just a, so that means this point is here. So this is a by 2 comma a. So these are the coordinates. So at this point and this point you want to find the magnetic field. Now we all know that this wire which carries current, okay, any wire which carries current will produce magnetic field around it. But on that wire, on this wire, if you join any line, anywhere on that line the magnetic field will be 0. Keep this in mind. So at this point, which is on that wire, on that extended wire, there will be no magnetic field because magnetic field is only produced around the wire, not on the line joining the wire. Yep, correct, it is 0. Yes, Gupta, we are doing all the topics. Welcome, Talapati. Yes, recording is no fun. It's always fun to attend live classes. Very true. So I hope you guys get it that the magnetic field at this point, the B will be 0. So this is my first answer. Okay, so this point has 0 magnetic field. Now for the second point, here is what I will do. What did I tell you guys? Whenever you have a finite wire and you are away from the wire, first thing, drop a perpendicular. So let's just drop a perpendicular. This is the perpendicular. Join the lines from the ends. Oh, the first end is this one. Okay, this is the first end. Okay, the second end is exactly this line. And mark the angles. One angle is alpha. The second angle beta is 0. Why? Because the second angle is making 0 degrees with the perpendicular. I hope you see that the second line that I will draw till the end will be that line itself. So alpha is here, beta is over here, which is 0. Now think about it. Do I know alpha? I think I know. Why? Because this is a right angle triangle. Can you guess what is the side length? Think about it. What is the side length? The side length over here is actually a. Minus a by 2 to plus a. The side length is a. And can you guess what's the height? Well, I think that's also very easy because the y coordinate is a. So this height is also a. So obviously this is an isosceles right angle triangle. That means this alpha will be 45 degrees. Correcto? Everybody got it? Yes. Let's move on. So what is the magnetic field at that point? So I'll first write down the formula mu naught I by 2 pi r. Sorry, it was not 2 pi r, it was 4 pi r. Okay, into sine of alpha plus sine of beta. So let's start substituting it. So mu naught I by 4 pi r. What is r? R is this distance, which is how much? It is nothing but a. Sine alpha, sine 45. Okay, plus sine beta, well that's 0 because beta is 0. Now what is sine 45? Sine 45 is 1 by root 2. So root 2 will come here. So 4 root 2 pi and a. So that is the magnetic field. Done, done, done. So I found the magnetic field on this line, which was 0, because on that line there is no field. Field is always produced around it. And when you want to find the field here, use the finite wire formula, which I gave you over here. That's it. Done, done, done. So Dalson, it's very simple. See, even if you take a wire like this, okay, and you are over here, what will be the, angle which alpha and beta will make? Or forget that. If you have a wire, okay, there will be magnetic field which will be created around the wire, not on the wire, right? So when you're on the wire, what will happen? The field will be 0. The field around the wire is not 0. Keep this in mind. So that's why when you're on the wire, then there is no field. I hope that makes sense. Okay, no problem, Amina. Glad to know that Google Math. Clear? Let's move on to the next one, if this is clear. So remember, whenever you see a straight wire, on the extended wire, there is no field. Never. Got it? Okay. Okay. Yep. Yes, Gupta Akash, I'm just doing questions like you can see. Yeah, these are the answers. We are doing more questions now, Gupta Akash. So theory and problems. Theory and problems, Gupta Akash. Okay? बनाए रहो, बहुत सारे क्वेश्चंस होने वाले, इससे आपके कॉन्सेप्ट्स क्लियर होंगे. So don't worry, your concepts are going to get cleared now. Okay, so there is a current which is flowing in this circular wire. Actually, this is supposed to be arc, not R. Arc of wire whose radius is R, which subtends an angle 3 pi by 2. Interesting. At its center, the magnetic induction or magnetic field at the center is how much? Let's do this. Okay. Let's do this. How many of you can get the answer? Come on, my warriors. So, first of all, if this was a complete loop, okay, if it was a complete loop, then what is the magnetic field? Mu naught I by 2R. This is for a complete loop. But now, the angle which this arc is subtending is 3 pi by 2. 3 pi by 2 radians is what fraction of the entire loop? Think about it. 3 pi by 2 as compared to 2 pi radians is what fraction? 270 degrees and 360 degrees. It's 3/4 of a loop, right? So if you multiply this with 3/4, what is this? This is the fraction of the arc. Okay, this is the fraction of the arc of that complete loop. So that is going to give me the magnetic field. So yes, so it will be 3 mu naught I by 8R. So that is nothing but option D. And let's see how many of you got it. Oh no, Mahant, it is not B. Nope. This is for a complete loop. So this is not the correct answer. If that was a complete circle, then that would be the answer. This is not a complete circle. I hope this makes sense. Everybody clear about this, my warriors? Is that understood why I have multiplied it by 3/4? If it was a semicircle, then what number would I put over here? Think about it and let me know in the chat box. If it was a semicircle, then what number would I put over here? Think about it. Yeah. Then I would put half. Okay. If it was quarter, then 1/4. If it is 3/4, 3/4. That's it. Done, done. Okay. And those of you who think, no sir, I wanted to do by a formula. Okay, no problem. Mu naught I by 2R into theta by 2 pi. No problem. Put theta as 3 pi by 2. If you put theta as 3 pi by 2, what will this number become? Think about it. 3 pi by 2 into 2 pi. Pi and pi by. So 3 by 2 into 2, that will be 3 by 4. Anyways, you are still getting the same number. So guys, it really doesn't matter which way you go. The answer will come out to be the same. Option was D. Moving on to the next question. Hello Nishika, welcome aboard. Yes, Raise. Let's move on to the next one. A magnetic field at the center of the coil of N turns, which is bent in the form of a square of side 2L, which carries current I, is how much? Let's try and do this. Yep. So Gupta, I just started with the revision. Probably you missed it. Go back. In the live session, go back. I revised the theory at the start of the class and then I went to the questions. So go back a little bit. I've revised the theory and then I have come to the questions. Okay? Gupta Akash, let's move on. So first of all, let me draw a square. A beautiful square. Okay. So this is my square. Okay. And what do we have over here? The side length is 2L. That's what is given. And the question is, find the magnetic field at the center of the coil. That means over here. Okay. I have an idea. Since this loop is carrying some current, how about finding a field due to any one segment? And since there are 4 such segments, I'll multiply it by 4 to find the total field. Correct? So find the field due to any one wire and then multiply by 4 because all the 4 wires will give the field in the same direction. Okay. So to find due to one segment or one side, what you need to do? This is a finite wire. Can you see that? This is a finite wire and you are standing here. The first thing, what did I tell you? Drop a perpendicular. What is the length of this perpendicular? Since this is 2L, L and L, so obviously this will be L. That's the first thing you should do. Second thing, what did I tell you? Join the ends with that point. So join the ends with this point like this and maybe like this. Great. Now if this is L, we also know one thing. Since the side length is 2L, each part will be L and L. Fair enough? L and L. That's 2L. Oh, now I got some nice triangles over here, and you can guess what those angles will be. This is L, this is L, this is 90. Obviously this is 45 and this is also 45. So this is 45 degrees and this is also going to be 45 degrees. So alpha and beta both are 45 degrees. Got it? So now you just need to find the field due to any one such side. Due to one side will be mu naught I by 4 pi r into sine alpha plus sine beta. Let's substitute it. Mu naught I by 4 pi radius, or not radius, distance. What's the distance? L. So just put L over here. Sine of alpha. So sine 45. Sine 45 plus sine 45. Okay, so let's see what do we get. We'll get mu naught I 2 times 1 by root 2. So 2 into 1 by root 2 divided by 4 pi L. Okay, this 2 and this 4 will go. So it will become 1 by 2 root 2. That is the magnetic field due to one side. But we want the field due to the entire loop. So the magnetic field due to that square loop will be 4 times of whatever value you got over here. So mu naught I by 2 root 2 pi L. Interesting. 4 and 2 goes. So you will have 2 divided by root 2 into mu naught I by pi L, I suppose. But 2 by root 2, that's root 2 again. So that will be root 2 mu naught I by pi L. See if this makes sense. Now, the question over here is, there is a square loop of n turns. One turn will create this much field. So there are n turns. So that field, net field will get multiplied n times. So this will be n times. So just take this number and multiply by n. See if this makes sense, my warriors. Okay, so it's very simple. You have taken a loop, the magnetic field at the center was asked, that loop had n number of turns, the side length was 2L. So what we did was, instead of finding random things, we divided the square into 4 sides. Each side will create a magnetic field. We first found out the field due to one side and multiplied it by 4 because there are 4 sides. Eventually we also multiplied it by n because each square loop will create same magnetic field. So when there are n loops, there will be n times of that field. That's it. I hope that makes sense. Okay, why did we multiply by the third step? Why did I multiply by 2? Sine 45 plus sine 45. That's 1 by root 2 plus 1 by root 2. What is 1 by root 2 plus 1 by root 2? 2 times 1 by root 2. So that is why 2 times 1 by root 2. I hope that makes sense. Yeah, that is why I have multiplied it. 2 times of 1 by root 2. 1 by root 2 plus 1 by root 2 is 2 times of 1 by root 2. Fair enough, my warriors. Are you guys convinced? Can we move ahead? Salva Malnikantan. So we do not know that, but the expected dates would be anywhere around March. Okay, chalo, let's move on. And here is the answer. Yes, option A is correct. Beautiful question coming up on screen. Samriddhi, that's what I'm doing now, bacha. This is first term, a JEE revision. Yeah, that's what I'm doing. But for CBSE, if you want to do the revision, there are 2 options. One, wait for it on Enthuse, we'll do it. But that will be few in number. It will not be too many. Okay, because we have to take care of 12th standard and also the 11th standard, and we are more towards the JEE side. So we'll be doing the term 1 revision classes. But if you want only CBSE revision, only dedicated to CBSE, there is a crash course running on Vedantu. For only term 1 revision, it is 1,500 rupees. PC, MP, all the subjects, whatever you want will be completed. So go ahead, join it. It will be very good for you. Hai na? That's what you can do. Okay, Samriddhi. Chalo, let's see how many of you can get this answer now. The magnetic field or magnetic induction, one and the same thing, at the center of this, for this diagram will be how much? Let's see how many of you can get it. Okay, Yeah, Abhinav, we are going to have KVPI mock test tonight at 7:30. I hope you know there is a KVPI mock test, but that's for essay. Tomorrow we'll have it for SX, that's 12th standard. So first of all, try to separate it into 3 parts. 1, 2, and this is 3. Now, isn't it obvious that because of this wire and because of this wire, these 2 wires will have no contribution in the field. Why is that they have no contribution in the field? Because, think about it, when you extend that line, this point is on that extended wire. So whenever you have a wire and you have that extension, then at this point the magnetic field is 0. So if this is carrying some current, remember, magnetic field is only produced around it and not on it, on the extended line of it. Remember? So that is gone. Now, only 2 wires which create magnetic field are this one and this one. But remember, this wire carries current like this. It flows and it comes over here. So if one produces magnetic field inside, the other one produces the magnetic field outside. Keep this in mind. So hence the net magnetic field will be, which one will be more? The one with the smaller radius will have more field. Okay, the one with large radius, because you are very far away, when you become very far away, the field reduces. So the field due to this one will be more because it is closer to this point O. When you go far away, the field is less. So it will be B1 minus B2. So what is B1? B1 will be mu naught I by 2 R1, but be very careful. This is the formula for a complete circle. This is not a circle, this is a semicircle. So you have to multiply it by half. Did you understand why I multiplied by half? Because for half a circle, exactly half the field will be produced. Minus mu naught I by 2 radius 2. But again, the outside circle is a semicircle. So that's why into half. So this half is because it is a semicircle. And that's it. You can see a lot of terms will come outside, like mu naught I by 4. And you will have 1 by R1 minus 1 by R2. Is that there somewhere? Yes, I think it is there over here as option A. Can you see that, my warriors? Yeah. Okay, so Vicky, I'll be doing optics as a part of term 2 syllabus, but if you are very eager to see those classes, I've conducted, a flash series last year. So you can watch the optics related flash series, but if you want to study as live class, you'll have to wait for it a little bit, because I'll be conducting optics as a part of term 2 as soon as term 1 is over. Okay, Vicky, let's go ahead. Limin, yeah, it was not B, it was A, bacha. It's not B. It will not add, it will subtract. Okay, so a lot of people make this common mistake. Yep, you can see it is option A. Moving on to the next question. This is a PYQ 2019 question. Come on, my warriors. Let's see how many of you can do this. Okay, this will be very interesting. Very, very interesting. Okay, as shown in the figure, there are 2 infinitely long wires which are bent by 90. So you had a wire, you bend it by 90. This is one wire, this is another wire. This wire has current which flows like this. This wire has current which flows like this. Fair enough? Okay. Now, OP is equal to OQ is equal to 4. This is 4, this is also 4 centimeters. And the magnitude of the field at this origin is 10 to the power minus 4 Teslas. Okay, the 2 wires carry equal currents. The magnitude of the current in each wire and the direction of the field at point O will be. Okay, great. Let's do this. Now, RayFS, yesterday only I have conducted a small 15-minute session, live session. Check out the description box of that session. In that, the first link points towards the schedule of the term 1 examination. Okay, so first of all, try and understand that there are some wires which will not have any contribution. Out of LP, PS, MQ and QN, respond to me in the chat box. Respond to me in the chat box. Which of these segments will not have any contribution at point O? Come on, think about it. Out of LP, PS, MQ and QN, at point O, which wire segments will not have any contribution at point O, because that is crucial for solving this question. This is a PYQ 2019 question. I just gave you one rule. And what is that rule? If you are having a wire which is carrying current, there is field only produced around it, not on it. On it, the field on the extended line, the magnetic field produced is 0. Yep. So think about it. No. Which wire, when you extend it, passes through point O? Which wire or wires, when extended, passes through point O? Think about it. Well, it's only LP and MQ. You can see this wire, when extended, passes through O, and when this wire, when extended, passes through point O. So these two wires have no contribution. They have no contribution in the field. So don't even worry about them. Just don't worry about them now. Okay, interesting. That means I need to only worry about PS and QN. Fair enough. Now, PS, the current is going up. The field will be around it like that. PS is going up, the current. So the field will be around it like this. So at point O, the field will go inside. The field will go inside. Make sense? So I'm showing a cross at point O. What about QN? QN, the current is going down. So the magnetic field will be like this. Okay, the magnetic field will be like this. That means it should go like that. Oh, on the left side of this wire, the magnetic field is again going inside. So the field due to PS and the field due to QN, both are adding together. Both are adding together. Make sense? Ganpati, you can see the KVPI crash course till the end of KVPI examination, bacha. So the lectures will be available to you till the last date, even if the exam gets postponed. Okay, don't worry about it. Acha. Now look at this. See, this wire is at some distance from this line, and this wire is also at the same distance from this wire. That means they have equal contributions. So can I say SP and QN contribute equally? If they contribute equally, you know, why do you want to keep that QN wire on the right hand side? Bring it on the left hand side and flip the direction of the current. I'll repeat again. This wire which is carrying current down is producing magnetic field inside. So if I take this wire QN and bring it over here at the same distance, just reverse the direction of the current, then you will see that wire will still produce magnetic field inside of the same magnitude. So that wire QN, which is on the right hand side, I might as well redraw this. So I'm redrawing this as if that point O is over here, and I have one single wire. I have one single wire like this, and that is S, P, and then we have N. The current is going like this, and you are at some distance over here. Isn't this like an infinitely long wire now? Isn't this like an infinitely long wire? So all these random things have now finally condensed, converted. I have redrawn it into one long wire which is at some distance, and that distance is basically 4 into 10 to the power minus 2 meters, which is 4 centimeters. So now I know the formula. Anirudh, yes, bacha, I will be doing. Yes, moving coil galvanometer. Yes, tangential galvanometer is not a part of syllabus. It's been removed now. Okay, so just use the formula and see what do you get. So the formula was magnetic field is, okay, mu naught I by 2 pi r. So what is B? B is 10 to the power minus 4. Mu naught is 4 pi into 10 to the power minus 7, standard value. The current is what exactly you need to find out. Divided by 2 pi into 4 into 10 to the power minus 2. Fair enough? Okay, so this 4 goes, pi also goes. So 10 to the power minus 4 is equal to 10 to the power minus 7 into I, and 4 has gone, this 2 is remaining, into 10 to the power minus 2. Okay, bring that terms over here and see what do you get. You'll get 2 into 10 to the power minus 4 minus 2 and plus 7. So just check this out. That should become 10. So basically it will become 20 amperes. So 20 amperes. Where is 20 amperes? It's there here and here. Okay, you can see here as well as here. Perpendicular out or perpendicular into the page. Just check this out. It's not out. Out will be this way. Into will be this way. So we saw that the magnetic field was inside. Hence the option that you should mark will be option C. Done, done or done. See if this is clear. Hi everyone. Welcome aboard. Welcome aboard. Yep. Glad to know that, Nikhil. Okay. So this is what this problem was. It looks complicated, but two of the wires didn't even contribute in the field. This wire and this wire had equal contribution. So what I did, I took this wire, shifted it here, and then I redrew it as one single wire because I know the formula for one long wire. It makes it look very simple. Then just substitute the values, solve it, simple calculations will give you the answer. Done, then are done. Okay. Yeah, I know it looks scary. So that's why if you keep attending my classes, you will slowly remove that fear of problem solving. A lot of people have that fear of problem solving, and basically the reason is, number one, you don't have the right mentor or mentorship. Number two, you're not solving problems from easy to difficult level. Number three, you're not, showing that full dedication, or you're not probably, trying enough, or you give up too easily. So when you give up very easily, then you will never be able to think on your own when the actual problem comes in the exam. So try to think even if you do not get it. Maybe you will get at least 2 steps out of the 5 steps. Maybe after 1 month, maybe you might get 3 steps. Maybe after 5 more months, you might get 4 steps. Eventually, you will get to all those 5 steps. Okay? So don't worry, just hang on there. Okay. Now, before going to the next point, remember, if you have any kind of doubts while solving problems, you can definitely ask our doubt experts. Please download the Vedantu app. You can ask unlimited doubts. You can chat with our doubt experts. They are proper subject experts. So your doubts will go to the respective subject teachers and you will get your doubts solved instantly. You can also ask if my solution is correct or wrong. And this goes on from morning till night every day. So this is a very important feature and it's completely free for all the pro subscription students who are in the classic and the plus versions. Okay, so make sure you completely make use of this app. And if you're not a part of pro subscription, then probably you should look forward to joining it, because this is one very good feature where you don't have to really depend on online sources or depend on friends, because you don't know whether they are correct or wrong. Let's move on to the next one. But before that, remember, you can join our Telegram group link so that you can get the entire PDF of today's session, and you'll also get all the important updates and our next class notification. Now let's move ahead to Ampere's law. Oops, Anirudh, don't worry, it's not for no reason, it's okay. Having extra knowledge is good. You studied it, no problem, Anirudh. So just hold on, I'll teach you moving oil galvanometer also in the next few days, okay? Chalo. Wow, Dalson, you're a pro student. Nice to know that. Okay. Chalo, let's do this. Ampere's law and the problems on that. Everybody knows Gauss's law. Very similarly, you have Ampere's law. Why did you use Gauss's law? That was used to find out the field due to different geometries, which was otherwise difficult to solve. Same way, Ampere's law is useful for finding the magnetic field, not electric field. To find the magnetic field due to different geometries, which otherwise would be difficult to solve via summation, integration, vector addition, God knows what. So this helps us solve the problem in an easy manner. What is Ampere's loop law? So you have bunch of wires which are creating field. Okay, let's say this is a wire which creates a magnetic field. You imagine a loop, a path which is closed in nature. You start from a point and come back to the same point. This is imaginary, it's just there in your head or on the paper. It's not a physical path. At every point there will be some magnetic field. You calculate that magnetic field and take the dot product with the displacement. You move to the next point, you displace to the next point, At that point there will be some new magnetic field. Take the dot product of that magnetic field into the displacement, and you keep on taking the dot product of magnetic field and displacement at every point on that path till you return back to the same point. And when you return back to the same point, okay, so according to this law, the magnetic field along that imaginary path is equal to the product of permeability of free space and the current enclosed by it. So when you take the dot product with the displacement and you come back, when you come back, that means it's a closed integral or a line integral, closed line integral. That means, you know, you're coming back to the same point. That is why this circle is shown. You are coming back to that same point. This cyclic integral B dot dl will always come out to be mu naught. What is mu naught? That's the permeability of free space into whatever current is there inside this loop. Whatever this current is there inside this particular loop, not the currents which are outside. This looks very similar to Gauss's law, where you had E dot dA is enclosed charge by epsilon naught. Instead of that, here you have magnetic field. Instead of area, you have length. Instead of permittivity, you have permeability. And instead of charge, you have current. How many of you can see the resemblance of this law with Gauss's law? Come on, think about it. Yep. Yeah, Ritesh, how do you know? My God, looks like you guys discuss everything. Yep. Come on. Yeah. So the previous problem which I did was means KVPY level. Yeah, that's what it was. The previous problem, PYQ means KVPY level, KVPY SX maybe. Yeah. So this is very important. Okay. Now there is a sign convention for this current. Which current is positive? Which current is negative? Now you can see the currents over here. You can see the currents over here. One is going this way, one is going this way, one is going that way. When I say enclosed currents, all of them are enclosed currents, but you cannot add them. You cannot say 5 plus 2 plus 6. That is completely wrong, because one is going this way, one is going like this, one is going that way. So how do you decide the current? It depends on how you are going around the loop. For example, this is my imaginary loop. I go like this and come back over here. Okay, I go like that. This is my path. Use your right hand. Curl your fingers. Curl your fingers along the path. See where your thumb is. Wherever your thumb is, that is positive. That way is positive. That means this is positive. This is positive. This is exactly opposite to my thumb. So this is negative. So the total current will be 5 plus 6 minus 2. That's 11 minus 2, which is equal to 9 amperes. Understood? Clear? So this is how the rule works. Always see how you are moving around the path. So always see the way you are moving around the path. Curl your fingers. The thumb will point in the positive direction of the current. That's the rule. Very good. Somebody saw the resemblance. Hello Alka, hello Dr. Alka Yadav. Welcome aboard. I'm very good. I hope you two are doing very fine. And if you have joined in late, all my warriors, do not worry. You can even now, you can go back in the live stream, come to the current point at 2x speed or 1.5x speed. Okay, you can do that still. And if you don't want to do that, you want to continue from wherever we are, please do that. You can watch the replay after the session ends. All right. So let's move ahead and let's see the field due to different geometries by Ampere's law. Hello Sarathi Vijay. Why is 2 negative? Because it is opposite. Because it is opposite to the thumb. You can see how is my loop like this. This direction is positive. You can see the current here is going against my thumb. My thumb was going up. This is going down. So that's why it's considered as negative. See, charges are very easy. Protons are positive, electrons are negative. How do you decide current, whether it is positive or negative? So that depends on how you are going around the loop. So the ones which are in the direction of thumb, positive, ones against the direction of thumb, negative. Is the direction of velocity and displacement same? Well, instantaneous velocity and instantaneous displacement, yes. Otherwise, maybe, may not be. Okay, so if you are talking about average velocity and instantaneous displacement, they might be different. But average velocity and total displacement, yes, they will be same. Okay, hi, Rakesh Kamila, welcome aboard. So, field due to a cylindrical conductor. What is this? See, you have a conductor like this, okay, and it carries current inside it. Okay, there is current which is flowing inside it. Then there will be magnetic field around it and also inside the conductor. Yep, inside the conductor also there is magnetic field. Only at the center the magnetic field is 0. Remember, just some time back I told you, if you have any wire and if you extend it exactly on that extended line, the field is always 0. So on the axis the field is 0, but everywhere else apart from it there is going to be field. And what are these arrow marks? These are basically your current, and the current is flowing in this entire cross section. So the question is, what is the field inside the cross section and outside the cross section? You should know this formula, very, very important. You can see this wire is carrying current I. If you are inside, look at this R is inside this blue dotted line, you can see that. That's how the magnetic field lines will move inside the solid conductor which is carrying current. That solid cross section which is carrying current will have magnetic field lines like this, that blue dotted line. You can see that. Okay, so that formula is mu naught I by 2 pi r square. Usually you had mu naught I by 2 pi r. This is r square. If you increase the dimension in the denominator, you need to add 1 dimension of length on the top. So you put small r over here. What is small r? Small r is the distance from the center. What is capital R? Capital R is the radius of that cylindrical conductor. So this r is less than capital R. Fair enough? Yes, this is a part of CBSE also. Yeah, we started the session at 5:30, bacha. Okay, but when you're outside, it's your standard formula. It's nothing but mu naught I by 2r. Yep, mu naught I by 2r. That's it. Very, very easy. Done, done. So this is when you're outside, this is when you're inside. This formula you already know. Mu naught I by 2 pi r for a long straight wire. But when you're inside, that's the formula. And the graph looks something like this. See, when you're inside, okay, this is the inside part, it is proportional to r. You can see that r is proportional to b, or b is proportional to r. It's in the numerator. But the moment you go outside, okay, you can see this r is there below. So it is inversely proportional to r. So it increases and then decreases. But this is linear, this is non-linear. Very, very important. Keep this in mind. Next formula. Field due to a solenoid. What is a magnetic field due to a solenoid? Well, what is a solenoid first of all? If you take a wire and wind it number of times, then the magnetic field which is produced inside the solenoid looks somewhat like this. Outside the solenoid, when you are far away, outside the solenoid, the field is negligible. You can see the spacing between the lines is very far. There is negligible field around the solenoid, but most of the field is inside the solenoid only. And that field is given by mu naught Ni by 2 sine alpha plus sine beta. Like, what the hell? What is sine alpha plus sine beta? And nobody told me this ever. See, if I'm at some point over here, I want to know what's the field. Draw a perpendicular. Draw the end, connect the end to the point and connect the other end to the same point. This angle is alpha and this angle is beta. So if you shift the point inside the solenoid, this alpha and beta will change accordingly. So different points will have different field. So alpha and beta are exactly that. I is the current, mu naught is the permeability. What is N? Is the number of turns per unit length. Keep this in mind. Now, if you are inside the solenoid and the solenoid is very long, so if you have a very long solenoid, then alpha and beta both will be 90 degrees. So you will get mu naught Ni by 2 sine 90 plus sine 90. Now what is 90 sine and 90 sine? It is 1 and 1. 1 plus 1, 2. 2 and 2 cancels. So what will you get? Mu naught Ni. So this is your usual formula for a long solenoid. But when the solenoid is short, then you use this formula. Is that clear? Ritesh, no bacha, not me. Okay, I'm already occupied in different things. Yeah, so this will be alpha and beta if it is short, but if it is long, alpha, beta both 90. So it will become just mu naught Ni, which is the formula which you usually study. So magnetic field well inside a long solenoid is mu naught N current. Okay, very, very important. Now what's a toroid? Toroid is nothing but a solenoid which is just connected back to back. Look at that. This was a solenoid. Okay, imagine I bend this solenoid and I connect it. So the field lines which were coming out, they will not be able to come out. They will be trapped inside that chamber. This chamber, they will be just trapped. We just connect both of them. So you just circulate inside that chamber, and this is nothing but called as a toroid. So the formula for a toroid should be the same as the formula for a solenoid. Just that usually people write it like this, and many people think, oh, this is a new formula. But remember, this N is total turns. This is the total turns. Actually speaking, this is mu naught N by 2 pi r. What is this 2 pi r? It's the length. It's the length of the toroid, which is also basically the circumference. It's basically the circumference. So basically I'm talking about this length. This length is 2 pi r. What is r? R is this radius. So it is nothing but mu naught N I. That's it. Because this N stands for capital N by 2 pi r. So this is a formula for nothing but a solenoid. As simple as that. So the formula for solenoid and toroid is exactly the same, but many people write small n as capital N, total turns by total length of that toroid, which is 2 pi r. Outside, obviously the field is 0 because the field lines will be trapped inside. Nothing can go outside the toroid. So everywhere outside the toroid, the field will be 0. Okay, fair enough? Clear? Okay, let's move ahead to the next concept. Field due to a sheet. Everybody knows that when you have a charged sheet, then the electric field due to that is given by sigma by 2 epsilon naught. Same way, if you have a sheet which carries current, the currents are flowing parallel. There is a sheet in which the wires are laid parallel to each other. It will create a magnetic field around it. So on the top, if the magnetic field lines go here, and they'll go from the end and come back, and they'll go like this, go to that side, come back like that. So you will see magnetic field lines going like this, and they will go there and come back from here like that. So you will see there will be a uniform field created, a uniform field just like you had a uniform field created over here due to this charged sheet of, this sheet which is charged uniformly. So there will be a uniform field created in case of electric field. In case of magnetic field, the field is again uniform. The formula is very similar. Magnetic field will be, again put that number 2. Instead of sigma, you will have lambda. And instead of 1 by epsilon naught, whenever epsilon comes below, mu naught goes on the top. If epsilon goes on the top, mu naught comes below. Always. So just put mu naught. So mu naught lambda by 2. If you are wondering what this lambda is, this is how much current is there per unit length. So if you take 1 meter, okay, how much current is flowing? So current flowing per meter, lambda amperes per meter. So the current per unit length, which means ampere per meter. Very, very important formula. Okay. So the regular timing of 12th batch session, well, that's going to be usually 5:30 or 7:30. Most of the days I'll try to conduct at 7:30, but if it is not possible, then 5:30. So that's why I posted an poll some days back, which is the most convenient time. So either one of them, okay, either 5:30 or 7:30. So lambda is the current per unit length, then the sheet produces uniform field, which is given by mu naught lambda by 2. Okay, let's start solving some questions. First question up on your screen. Come on, my warriors, figure this out. What should be the answer? What do you think? Rishabh, this is an English channel, so I'll be speaking only in English. So that's one thing, because we are focused towards the English medium students who are studying in English medium. Yeah. So I'm sorry about that. All right. So let's go ahead and let's try and solve this question. Question is, if there is a long hollow copper pipe which carries direct current, the magnetic field associated with the current will be only inside the pipe, only outside the pipe, neither inside nor outside, both inside and outside. Okay, so this is a hollow pipe. This is our hollow pipe and it is carrying current, okay, like this. It's carrying direct current like this. Okay, so when it carries current, okay, this is all current, then think, if I draw an Amperian loop, so what is this? This is an Amperian loop inside, then it will look something like this. The integral will be B dot dl will be mu naught into enclosed current. What is the current inside this loop? Well, the currents are only going outside, you can see that, so that will be 0. So obviously this B will be a big 0. So magnetic field inside will be 0. But when you take an Amperian loop like this, if this is my Amperian loop, then you will see when I do cyclic integral B dot dl is mu naught into I enclosed. There is lot of enclosed current you can see over here. And see, all this is enclosed current within this entire big loop. You can see these are all the enclosed currents. So this B is obviously not 0 outside. So where is the field? The field is only there outside the pipe and not inside the pipe. Hence the correct answer should be only outside the pipe. Is that clear, my warriors? Everybody got it? Chalo, next question coming up on your screen. Let's see how many of you can do this. Very simple question. Direct substitution, you should be able to get it within few seconds. There is a solenoid of 1.5 meters length, 4 centimeters diameter. It has 10 turns per centimeter. The current is 5 amperes. What is the field inside the solenoid? First of all, try to visualize it. 1.5 meters and diameter 4 centimeters. So it's a very long solenoid. So you can think of it like a long solenoid. And for a long solenoid, we know what is the magnetic field inside of it. It is just mu naught small n I. So just do that. Use the formula and you'll get it, I'm pretty sure. So mu naught, so magnetic field inside, mu naught is 4 pi into 10 to the power minus 7. This is 10 turns per centimeter. Do not leave it in centimeters, you need it per meter. 100 centimeters make 1 meter. Correct? 100 centimeters make 1 meter. So there are 10 turns in 1 centimeter. So in 1 meter, or basically 100 centimeters, there will be 10 into 100 turns per meter. Current, well, the current is 5 amperes. What do I do with this and this? This is useless information for calculation, but only to understand this, and this piece of information only tells me that it is a long solenoid. Nothing else apart from that. It will not be used as such in the calculation. So 4 5s are 20. So 20 pi into 10 to the power minus 7 into 10 to the power 3. So this will be 2 pi into 10 to the power minus 7, 10 to the power 3, 10 to the power 4, 10 to the power 4, 10 to the power minus 7, 10 to the power minus 3. So 10 to the power minus 3 Tesla. So where is 10 to the power minus 3 Tesla? That's option C over here. Oh, sorry, my bad. I think none of the options are matching. Oops, I think there was some mistake in the options then. Okay, yes, I think there was a mistake in the options. It was supposed to be, yeah, 2 pi. I think that 4 pi came by mistake. Yeah. So there is a printing mistake, guys. I'll just erase this. This was supposed to be 2 pi. Okay, I'll change it in the actual PDF. Don't worry about it. Yeah, so it was 2 pi into 10 to the power minus 3. All right, moving on to the next question. Okay, and here it is. Again, this is a PYQ. There is a long solenoid which has 200 turns. per centimeter and it carries current I. The field inside is this much. You take another solenoid, it has 100 turns per centimeter and it carries current 1/3 of the previous current. What is the value of this field inside? Okay, chalo, let's do this. Few more questions to go. The class will go until almost like 7 o'clock because 7:30 I have my next class with you guys only. Okay, so what is the formula usually for solenoid? It is mu naught Ni. So let's use this. The new magnetic field upon the old magnetic field. The old magnetic field is 6.28 into 10 to the power minus 2 will be equal to mu naught will come both ways. Okay, then number of turns now and before. This has 100, the previous one had 200. So this one has 100, the older one had 200. Okay, the newer one has current I by 3, the older one had current I. This is what it looks like. So B new will be, take this guy over there. Anyways, you can see a lot of terms will get cancelled. Mu naught, 0, 0, 0, 0, I. So take this on that side and what you will get is 6.28 into 10 to the power minus 2 into half into 1 by 3. 2 3s are 6. So 6.28 divided by 6 into 10 to the power minus 2. This will be almost like 1. So almost like 1 point something into 10 to the power minus 2. So I think this should be the answer. Yeah, you can see that. 6.28 divided by 6 will be almost like 1 point something, which is 1.05. Very good. Excellent. So let's move on to the next one. So I hope you understood the calculations. Yeah, the option is A. Moving on. Okay, no problem, Ritesh. I'll have a look. So there is a long straight wire of radius A and it carries current distributed uniformly over its cross section. The ratio of the field due to the wire at a distance A by 3 and 2A respectively from the axis of the wire is. Okay, first let's draw the diagram. Okay, so this is my wire. Okay, this is the cross section. The cross section's radius is A. The first part says at a distance of A by 3 and then at a distance of 2A. A by 3 is less than A, that means you are inside. So the first part is when you are inside. Okay, so think about it. When you are inside, there will be some magnetic field. And by the way, that radius is given to be A by 3. So there is magnetic field here. And when you are outside, because 2A is more than A, so there will be some different magnetic field. So I'll just put it here like this. And this one over here is basically 2A. So this is for out and the green one is for inside. So the question is, what is the magnetic field when you are inside? Okay, B in upon B out. So let's figure this out. Okay, first of all, what is the formula when you are inside? When you are inside, I just gave you that formula. It was mu naught current divided by 2 pi radius of the cylinder square, A square, into the distance from the center, which is A by 3. Okay, I'll just put it over here. Divided by. When you're outside, the formula, remember I just gave you that graph, straight line and then curved, is proportional to R, then 1 by R. Remember I just gave it to you just some time back. So here it will be mu naught I by 2 pi R. R is the distance from the center, which is just 2A. Okay, now you can see a lot of stuff will get cancelled like mu naught, I think one of the A over here and this A square, this A and this A, pi and pi. So many terms got cancelled. So on the top you just have 1 by 6 and over here you have 2 into 2, which is 1 by 4. So that 4 goes on the top, correct, and that 6 comes below. So you just cancel it and see what you get. You will get this as 2, this will be 3. So 2/3 should be the answer. Done, done. Is that clear, my warriors? I don't know that, but I think it should be mains. Yeah, it's straightforward only. It's not that difficult. Even if it comes in advanced, it will be in the single choice questions, not more than that. Okay, so you had to know both the formulas for magnetic field inside and magnetic field outside. Only then you will get this. Otherwise, probably you will make a mistake. Okay, moving on to the next question coming up on your screen. Option A was correct. Well, let's see how many of you can get this. B1, B2, B3 are the magnetic fields due to I1, I2 and I3 in the Ampere's formula, Ampere's loop law formula. B dot dl, okay, is equal to mu naught I. Here this B is the magnetic field due to wire 1 and wire 2, wire 1, 2 and 3, or wire 1 minus wire 2 and then wire 3. What do you think? Okay, think about it, my warriors. Figure it out. Come on, my warriors. Yes, I do have Telegram account, but it's very difficult for me to see. Yes, let's do that. One more problem. In fact, a lot more questions coming up. Alka, yeah, don't worry. Is it possible to score 200 out of 300 in 100 days for JEE Mains? Yeah, very easily, modern man. Yeah, you can do that. Why not? If you start attending my series, if you watch all my classes regularly, you can do it. If you start solving lots of questions, obviously you can do it. So yes, you can do it. Many students have done it. In fact, students have got even 240 marks. So obviously, why not? Just be regular, be patient, solve lots of questions, you will get it. Okay, so what do you think the answer is? Well, this B is always the magnetic field due to all the other magnet, all the currents, be it inside or be it outside. That's very important. Where it go? Yeah. B is B1 plus B2 plus B3 vector sum. Yep. So it is always the vector sum of all the magnetic fields. This wire might create, so when I say it's B dot dl, dl is like this. What is this B? B is the magnetic field due to this one and this one. So this is the sum of all the currents, be it in or be it outside. It really doesn't matter. Remember, even in Gauss's law, when I said E dot dA is equal to, Q in by epsilon naught, although the RHS has only inside charges, this field is because of both in as well as outside charges. Always this is true. Keep this in mind. Yep. 99 percentile in mains. Well, that should be close to around 180, 160 marks, around that out of 300. So if you are getting 200 marks, easily you are above 99 percentile. Last question I believe for today. A toroid has a core of inner radius 10 cm, outer radius 12 cm, which has 3500 turns of wire which are wound on it. If there is a current of 11 amperes, what is the field at the center of the core of the toroid? Hello Anil, welcome aboard. I think you disappeared meanwhile. Okay, so let's see how to do this. First, let's draw that toroid. Okay, this toroid is like this. As per the question, the inner radius is 10. So this is 10. And the outer radius, well, that is 12 centimeters. That means the average radius, which is this one, because you will neither take the inner one nor will you take the outer radius. So this is basically the average radius, will be neither 10 nor 12, the average of that, which will be 11 centimeters. So the question is, what is the magnetic field over here? Use the formula, okay, and you will get it probably. So B will be mu naught N I. This small n is nothing but number of turns divided by 2 pi r into I. So what is mu naught? Mu naught is 4 pi into 10 to the power minus 7. Is that right? Everybody getting it, my warriors? Okay. Now what is the value of capital N? Capital N is 3500. So this is 3500 divided by 2 pi into this r is this average radius, which is 11 centimeters, matlab 20 to the power minus 2 into current. Current is 11 amperes. Okay. So I think a lot of things might get just cancelled, like this pi over here, this pi over here. This 2 with this 4 goes with 2, this 11 and this 11. Okay, so let's see what are we left with. So 2 into 35, that's 70, into 10 to the power minus 7 into 10 to the power 2, because I just multiplied 35 with 2, and we had that 2 zeros over here. This 10 to the power minus 2 goes on the top and becomes 10 to the power 2, nothing else. So this will become 7 into 10 to the power 2, 10 to the power 2, 10 to the power 4 into one more 0, 10 to the power 5 minus 7 plus 5 minus 2. So 7 into 10 to the power minus 2, which is 0.07 Tesla. That should be the answer. How many of you got it? Yep. Welcome aboard, everyone. Those who are joining in late, you missed quite a bit of the class, and that was the answer, I believe. Yes, it's 0.07 Tesla. What a brilliant answer. So the last homework question for you. So do not forget to post the answers in the comment section below. It's based on sheets. This sheet is carrying current here. This sheet has a current density of 2 lambda. It's carrying current here. What's the magnetic field in this part, and this part? So figure that out and put up the answers in the comment section below. Now there are 2 important announcements that I need to make. Number 1, if you want to prepare for term 1 examinations, we have a crash course going on along with lot of things like assignments, test series, mock questions, the best teachers in that field, along with many other micro courses. And these batches are in English. Also, there is an offer going on because there is a festival going on and Dashera. So we need to give you some really cool discounts. So here is what it is. Observe this. There is a CBSE batch, there is a NEET batch, there is a term 1 crash course, there is a NDA batch, there is a KVPY batch. So many courses which are available just for you, and that too with material, questions, along with live recordings, also with tests and lots of assignments. And you will get the best in class teachers which are specialized in teaching for the respective domains. And all of this at a very affordable price. So where do you get to see all of that? All you need to do is, if you are on our channel right now watching it, just go below. Okay, just go below. You will see over here, avail all Vedantu's courses and get 50% off. Usually you do not get 50% off, you get 10% off in regular times. But today is a special time. This time you're getting 50% off because of EdFest. There is this Dashera offer. So if you're in class 12, you can go ahead and click this link. If you're a dropper, click this link. If you just want a term 1 crash course, click on this link. You can see the crash course price. This is 3,000. When you use my coupon code, you will get a 50% off. So that's what happens. So all these prices will come down. So you can click on the respective links, and that's how you can join the crash courses. So go ahead. The time is not yet over because I feel that you still have good 1.5 months of time. And when you go to class 12 pro subscription, not only will you get JEE related classes, but the CBSE class also becomes free. And you have these 3 versions. Okay, light, classic and plus. Light is everything, whatever I told you, you will get. In the classic version, you get doubt solving on the mobile app. And on the plus version, you will get personal mentorship. Now these prices are per year prices, but you can also try it out for 1 month. You can see 50% off for 1 month price. But if you want to buy the complete course, that option is also there for you. See, the coupon code will help you get the best discount. That's what it is. Okay. So make sure, if you are not, still convinced about buying the complete course, you can try it out for 1 month. 1,700 is not at all a big amount. You can definitely try it out. You will get your CBSE crash courses. You will also get your regular JEE courses and everything that you should get for regular coaching. So try it out for 1 month at least. That's what you can do. So that's it from my side. I'll be seeing you, especially the 11th standard kids, after half an hour in the KVPI SA mock test. Tomorrow I'll meet you for the KVPI SX mock test. Every day you are going to have classes from me. So make sure you do not forget to hit the subscribe button and shower your love by smashing the like button. So what is the difference between magnetic needle placed in uniform and non-uniform magnetic field? Yeah. So here is what happens, Ritesh Sundar. When you place a magnetic needle, basically a bar magnet for example, in a uniform magnetic field, then the net force is 0. Torque will depend on the orientation. So M cross B will give you the torque. If they are parallel or anti-parallel, no torque. But if it is at some other angle, you will always get a torque. But when it is a non-uniform magnetic field, then most of the times you will see that the net force will not be 0. Okay, so there will be some net force and net torque will be there in most of the situations unless you align it in a very peculiar manner. I hope that answers your doubt. Alright, so thank you Dalston. I'm so glad you said that. I'm always here for all the South Indian, North Indian, West Indian, East Indian, outside Indian students. I'm always there for all of you. Bye bye Dr. Alka Yadav. Good night. Vanakkam Zayed. Take care. Have a great time. And yeah, please stay safe and please keep studying and please be regular and please get your friends along with you to this channel so that we can grow and machao fine. We can rock, we can ace it together. This was Captain Shreyas and I was going live. Hasta la vista.